When we train a large language model or a vision language model, we usually start with large-scale pre-training and later the model goes through reinforcement learning through human feedback. And methods like TRPO, PPO and more recently GRPO or Group Relative Policy Optimization improve model behavior by maximizing rewards while keeping the updated model close to a reference model using KL divergence. In other words, we improve the reward while keeping the model as close as possible to our reference model. However, these approaches depend heavily on labeled data and offline training stages. But humans do not learn this way. Humans continuously learn while interacting with the world, even without explicit supervision. In other words, we do not want a person to guide us through our day-to-day life. So TTRV brings this idea into vision language models by allowing reinforcement learning to happen during inference directly on unlabeled test data. So instead of adapting before deployment, the model adapts while solving the task itself. So here's the key idea. Given an image and a prompt, the model generates multiple responses for the same input. These responses form an empirical probability distribution based on how often each answer appears. The assumption is simple. Responses that appear more consistently are more likely to be correct. Each response receives a frequency-based reward proportional to how often it occurs. Unlike majority voting, all responses are kept and rewarded softly, which creates a smoother and more stable learning signal. This reward is then used inside group relative policy optimization, where responses are evaluated relative to others in the same group. But rewarding frequency alone could make the model uncertain or scattered. So TTRV adds a second reward based on Shannon entropy. Low entropy is rewarded, encouraging the model to gradually concentrate probability mass towards confident predictions. The final reward combines frequency consistency and entropy control. Using this signal, the model updates itself immediately at the test time, improving predictions without any human annotations. And interestingly, even adapting on a single unlabeled example can improve the performance. In short, TTRV transforms static vision language models into systems that learn from their own experience, moving reinforcement learning closer to how humans naturally learn through interaction with the world.